Hello, everybody. Welcome back to Easy Learn. And today's topic is trigonometric functions. And within this topic, we're going to be looking at sine, cos, tan. Now, to understand sine, cos, tan, it is important that we are well versed with Pythagoras Theorem. So, if you haven't watched my Pythagoras Theorem explanation video yet, just pause right here, go check the link in the description below, try to understand Pythagoras Theorem first, and then come back for trigonometric functions. To begin with, Pythagoras theorem tells us that we can use this theorem on right angle triangles. That means when we are dealing with the 90-degree triangles, that's when Pythagoras theorem can be applied. And the formula for Pythagoras theorem was a squared plus b squared equals c squared, where a and b were the horizontal and the vertical lengths, and c is the diagonal or the one that's opposite to 90 degrees. But when we're dealing with trigonometric functions, the situation slightly changes. The a and b turn into a and o, and the c turns into h. And the new formula that we have is a squared plus o squared equals h squared. Now the a is the adjacent, o is known as the opposite, and h is known as the hypotenuse. Now we're no more going to be using the basic Pythagoras formula that's a square plus b square equals c square. It has changed now. It becomes capital A squared plus capital O squared equals capital H squared. Now, normally in the basic formula, a and b were the horizontal and vertical lengths. But in this one, when we're dealing with trigonometric functions, there is a different way to analyze which one is the a and which one is the o. Moving on. So, when you're dealing with the trigonometric functions and when you have your right angle triangles and then when you have your O, A, and H, there is going to be another thing that you will always see, that is this, an angle. There is always going to be a small mark on your triangle. Other than the 90-degree angle, there is going to be this mark which indicates that there is another angle mentioned there, and this angle is going to be from 0 to 90 degrees. Now you can notice that we already have a 90-degree angle here, so we can't have the other ones as 90, but we are going to have an angle that would be in between from 0 to 90. Now, coming back to how do we understand which ones are A and which ones are O? So A is the length that is enclosed between the 90 degrees and the other angle given. So as you can see, there's an angle, there is a 90-degree mark, and the length that comes in between these two is our A, and O is basically the length that is opposite to the given angle. As you can see here, we have this blue angle right there, and the length that's right opposite to that is our O, or the opposite, okay? And the hypotenuse is the same as it was for the basic Pythagoras formula, the C, what it was, diagonal length opposite to the 90 degrees. So H remains the same. H is the diagonal length, but for A and O, you need to be very careful. The A is the length that is enclosed between 90 degrees and the other angle, and O is always going to be the length that is opposite to the given angle. Or we could also say that the length that is perpendicular to the 90 degrees, whichever you find convenient. Moving on. So, coming back to the sine cos tan and its usage. So sine, we the short form is sin, sine. Then we have cosine, and the short form for that is cos, cos. And then we have tangent, and the short form for tangent is tan. Okay, and then why is sine cos tan used? Now sine cos tan is used for finding lengths or angles of a right angle triangle. Now this is the one thing that's common between Pythagoras theorem and sine cos tan, is that it's used for right angle triangles, and one of the difference between the two is that Pythagoras theorem only deals with lengths, whereas sine cos tan deals with lengths as well as angles. Now, sine cos tan has a specific table. This table that you can see right here is a very important table which you need to understand and you need to memorize. So, before moving into the details of that, we just need to see that this table has something like this: sine, and below sine we have O, and below O we have H, and then cos, and then there's A and H, then there's tan, there's O and A. This O, A, H, these are um, the Pythagoras theorem that we just studied, that O is the opposite, A is the adjacent, and H is the hypotenuse. Okay, and how would you remember this? People have different ways of remembering the sine cos tan table. People mostly use this little abbreviation that says so ka to ha, where S stands for sine, and then O is the O just below the sine, and then C is for cos, and A is the one that's below cos, and T is for tan, and then there's an O, and then HHA is going horizontally, the HHA. So you can just try to remember it from this, and you could also make something of your own so that it's easier for you to remember. And another thing is that this angle that we spoke about, this angle has a specific name. This angle is called as theta. And the theta has a specific symbol, something like this, that's a cursive capital O. So whenever you are referring to angles of a right angle triangle, we can say that we're trying to find theta. Moving on. Now, sine cos tan has this table OH, AH, OA. Now, we need to analyze, or we need to know how to exactly implement this table. To implement this table, you need to grab out your sine cos tan individually and see how it works. So, again, keeping in mind that sine cos tan is used for finding lengths or angles of a right angle triangle, and we have the way we implement is like this. So sine theta is equal to O over H. Now you just can't take sine is equal to O over H. Sine itself is nothing. Sine of theta means that they're taking sine of the angle. Okay, sine of the angle is equal to O upon H, O divided by H, O over H. It's just not, we just don't simply write O and H like that. This table basically means that sine theta equals O divided by H. That's opposite divided by hypotenuse. Similarly, cos theta is equal to A divided by H, or adjacent over hypotenuse. And then similarly, we have tan theta equals opposite over adjacent. So this is how you implement the sine cos tan table. You need to know that with sine, cos, and tan, you always have the angle, and then after that you follow what the table says. So it says O and H, so O and H divided with each other, A over H and O over A. So this is how you go about. Moving on. Now let's suppose we have this right angle triangle DEF, and FE is 8 centimeters, and this theta, the angle E, is, let's suppose, 30 degrees, and the length FD is Y centimeters. Now you see, this is a right angle triangle. It's dealing with two lengths and it's dealing with one angle. Whenever you see right angle triangles and when you see two lengths and one angle, just remember that we're going to be using sine cos tan. Again, right angle triangles and sine cos tan go together. So for solving this question, we need to have a few things at the back of our head. That is the sine cos tan table. That is the fact that sine cos tan is used to find lengths or angles of a right angle triangle, and the fact that we implement sine cos tan using sine theta equals O over H, cos theta equals A over H, and tan theta is equal to O over A. Moving on, again to remember, A is the length enclosed between 90 degrees and the other angle given. O is the length that is opposite to the given angle, that's opposite. H is the hypotenuse, the diagonal length opposite to 90 degrees. Now coming on this example FDE triangle, you can see that we don't have a length that is enclosed between the 90 degrees and the 30-degree angle, we don't have the value of that length. But we do have the length that's opposite to 30 degrees, which means that I have my O, and we have another length that is right opposite to the 90 degrees, or the one that's diagonal, which means I have my opposite and my hypotenuse. So coming back to sine cos tan table, you can see that which identity is giving me my opposite and my hypotenuse. It's the sine theta equals opposite over hypotenuse. That's how you try and figure out which one to use, the sine, cos, or tan. It depends on the length or angle that is given to you. So I'm going to be grabbing out my sine theta equals O over H, and then I'm going to be replacing my theta with the value and my O and H also with the values given. So I'm going to be writing sine theta equals the opposite, which is unknown to me. They've given it as y. So sine theta, sine 30 equals y upon 8. 8 is the hypotenuse. Now I'm going to be taking my 8 to the other side. Now 8 is in division with the y, so when it goes to the other side, it turns into multiplication. So sine 30 times 8 equals y. Now here's the question, that what is sine 30? How do I figure out what is the value of sine 30? Now for that, you simply need to check on your calculator. You need a scientific calculator to solve this, and if you don't have one, you need to just go on Google and you can just type scientific calculator. You get this one right here. You can also choose any one of them from the links provided, but if you have it on top, you can just use this one. One thing that is important is that you need to set your calculator on degrees. Either it's your physical scientific calculator or the one you're using on Google. It is, you have to make sure that it is DEG, it is set on degrees, because for example, if I write, let's suppose, sine 60 in degrees, it's giving me 0.866. But if I do rad, and if I write the same thing as sine 60, now you see I have a negative 0.30 something. So this means that the answers in rad and in degrees, rad is the radians. So radians and degrees, the answers are different. That's why you have to make sure that your calculator is always on degrees until and unless the question asks you to give your answer in radians. Then you set your calculator to radians. Otherwise, you have to keep it degrees. Now you see here that below this degree we have sine, cos, and tan. Now I can write sine 30. Let's see what we have as sine 30. So we have 0.5, and 0.5 times 8 gives me 4. If I want, I can just simply write the whole thing together. So sine 30 times 8. Make sure that you don't miss this bracket close after the sine 30. Otherwise, it's going to give you a wrong answer. Sine 30, bracket close, times 8 gives me the same answer. It's 4. So we know that sine 30 was 0.5. 0.5 times 8 equals y, which means y is equal to 4 centimeters. So that means my length FD is going to be replaced with 4 centimeters. That's how you solve the sine cos tan problems. Let's look at another example. Let's suppose I have another right angled triangle with ABC and AB as 3 centimeters, AC as 8 centimeters, and my theta is, let's suppose, it's x degrees. Now, again, there are two lengths involved, one angle involved, and the angle is missing. So I need to figure out. Again, keeping in mind my basic stuff, and I know that sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. And keeping in mind that A is the length enclosed between 90 degrees and the angle, O is the length opposite to the given angle, and H is the diagonal length. Now you can see that AB is the length that is enclosed between the 90 degrees and the given angle. The angle is unknown, but that doesn't really matter. As long as there is an angle existing, it means that you can take the A. Now A is the AB, the length AB is my A, that's 3 centimeters, and the length AC, again, now we can see that the length that is opposite to the given angle is going to be my O, the opposite. So 8 is my opposite, which means that I'm going to be using O and A, the adjacent and the opposite. Now, coming back to the sine cos tan implementation, you need to figure out that which of them is giving me the opposite and the adjacent together. Sine does not give me that. Sine is giving me opposite and hypotenuse. Cos is giving me adjacent and hypotenuse. But the right one is tan. Tan is giving me the opposite and the adjacent. So I'm just going to grab it down there and I'm going to write tan theta equals O over A. And then I'm going to be replacing the theta, the O, and the A. So my theta is x. Tan x is equal to, opposite is the 8, and divided by 3. Now here's an interesting concept. Now let's suppose I have x plus 4 equals 10. If I tell you I want the value of x, what's the one thing that you do? You grab your 4 to the other side. Now 4 is positive on this side. When it goes to the other side, it becomes negative. So I'm going to be writing x equals 10 minus 4, right? Similarly, if I have something like this, 4x equals 2. If I tell you I want the value of x, what are you supposed to do? You'll be taking the 4 to the other side, which means that x is going to be 2 over 4 because 4 was in multiplication with the x. It goes to the other side, it turns into division. Similarly, if I'm dealing with tan x equals 8 over 3. Now, if I take this tan to the other side, what happens? It's not as simple as it was for positive or negatives and multiplications and divisions. We just switch them. But when tan goes to the other side, it becomes something like this. X equals tan minus 1, 8 over 3. And tan minus 1 is called as tan inverse. Similarly, when we're dealing with sine and cos, the same thing happens. When sine and cos travel to the other side, they become sine inverse, cos inverse. So this one becomes tan inverse. So x equals tan inverse of 8 over 3. Now, how do I find out the answer for this? Going back to my scientific calculator. Now, first thing, you have to make sure that your calculator is set on degrees. And then when I have to take inverse of tan or sine or cos, this is the symbol here that says I and V, that's inverse. And you will also have the same thing in your normal or physical scientific calculators, where when you press shift and you press the sine, cos, or tan, you will get the inverse part. So if I want to do this on Google, I'm just going to press I and V, that's inverse, and here you can just see that I have inverses: sine minus 1, cos minus 1, and tan minus 1. So because I'm dealing with tan for this question, I'm going to click tan inverse. So I have something like this arc tan, and that's 8 divided by 3. 8 over 3. So my answer is 69.4. So tan inverse of 8 over 3 is equal to 69.4. The x, or the theta, is equal to 69.4. That's how you find your answers to thetas when some specific lengths are given to you and the angle is missing. You have to figure out which lengths are available, either the adjacent, hypotenuse, or the opposite. Then you put them in for your sine, cos, tan, and then you just find out using the inverse. Today, if you have any confusions or questions, just drop them in the comment section below. Until next time, take care of yourselves. Do not forget to subscribe, like, and share Easy Learn, and hopefully see you in the next video. Thank you.